The landscape of artificial intelligence has shifted. The era of typing simple chat prompts and waiting for a response is over. We are now operating in an environment driven by complex ecosystems of autonomous agents. We no longer use AI as a basic digital assistant. The human role has evolved into managing these entire ecosystems, delegating sequences of tasks across networks of specialized bots. Whether you are an undergraduate planning your major or a mid-career professional aiming to pivot, the exact technical training you select right now will dictate your survival in this automated economy. The industry has split into two clear pathways, requiring two distinct personas: the orchestrator and the builder. The orchestrator optimizes workflows, decomposing business problems into tasks AI agents can execute. The builder architects the underlying math and neural networks that make those systems function. Committing to the wrong curriculum wastes thousands of dollars in capital and leaves you with an irrelevant skill set while the market moves on. Securing a role in 2026 requires looking past legacy university brand names and aggressively matching your specific career intent to highly targeted educational training. For non-technical professionals, the primary objective is mastering journey orchestration. Journey orchestration is the process of breaking down a large business objective into smaller sequential steps that autonomous agents can process. In entry-level roles, this frequently relies on vibe coding. Vibe coding is a method where users write natural language prompts to prototype and build functional software, entirely bypassing traditional programming languages. While accessible, this approach breaks down when applied to mission-critical systems. Operating at an enterprise scale requires strict data governance and security frameworks that natural language prompting cannot provide. This table outlines the primary online educational pathways for acquiring foundational orchestrator skills. It compares AI Essentials from Google, CS50 AI from Harvard, AI for Everyone from deeplearning.ai, and the IBM AI Professional Track. The financial barrier to entry is minimal. These programs operate on low-cost monthly subscriptions or offer free access with an optional fee to acquire the final certificate. They offer varying degrees of technical rigor. Google and deeplearning.ai focus heavily on workflow automation and ethics, while Harvard and IBM introduce hard logic algorithms and the basics of machine learning. These accessible tracks deliver necessary baseline literacy. However, if your intention is to physically code and deploy enterprise-grade AI architecture, this level of education is entirely insufficient. For those pursuing systems design on the builder path, the specific institution you choose for your engineering degree dictates your career trajectory. Carnegie Mellon University remains the elite destination. Their Master of Science in AI innovation bridges the gap between hardcore software coding and venture-backed product development. Stanford's professional program offers intense, math-heavy training in advanced fields like reinforcement learning, placing students directly inside Silicon Valley's tech hubs. This chart maps the trade-offs of the current educational landscape. Elite private institutions like CMU and Stanford sit firmly in the high-cost, high-theory quadrant. Students face exorbitant tuition costs, hyper-competitive admissions, and massive burnout risks. Public powerhouses have captured the lower right quadrant. Engineering leads favor these programs because their curriculums prioritize creating deployed code over writing theoretical research papers. Georgia Tech dominates this space by delivering world-class engineering education entirely online, resulting in exceptional financial return on investment. The University of Illinois Urbana-Champaign provides a highly specific advantage in hardware AI co-design, teaching students to optimize physical processors specifically for neural network workloads. An on-campus master's degree at a top private institution costs upwards of $52,000, while a practical, online master's from a public university costs roughly $7,000. Taking on massive private student debt is a mathematically sound choice only if the student explicitly requires elite C-suite networking. Otherwise, public programs offer vastly superior financial leverage. Many working professionals require deep technical upgrades, but cannot relocate or commit to a multi-year degree program. Harvard's TinyML online certificate has become the definitive standard for Edge AI. Edge AI refers to running machine learning models directly on local hardware devices, like microchips, rather than relying on cloud servers. UC San Diego offers a targeted quantum machine learning track. This curriculum provides the mathematical foundation necessary to design algorithms for quantum neural networks, preparing engineers for the hardware demands of the 2030s. The trade-off is scope. These online specializations sacrifice broad computing theory in favor of rapid, targeted mastery of specific toolsets. In a rapidly shifting market, these modular pathways provide high-value agility. Engineers adapt to niche hardware demands without interrupting their current earning potential. A legacy assumption persists that a prestigious degree guarantees top-tier employment. The hiring data contradicts this. This chart illustrates a critical 2026 hiring metric. Nearly 35% of the engineers working at elite labs like OpenAI and Anthropic are sourced from non-Ivy League and non-traditional backgrounds. Employers evaluate candidates based on a new currency, artifacts. Employers demand tangible projects over text-heavy resumes. They look for a live code repository where you fine-tuned a model for a specific industry or built a functional agentic loop. An agentic loop is a system where an AI continuously assesses a problem, executes a task, and evaluates its own success without human prompting. An engineer paying $7,000 for an online degree accumulates wealth and years of practical work experience simultaneously, while the student choosing the traditional prestige path faces significant debt before deploying their first commercial project. Because AI code is instantly verifiable, a rich portfolio of functioning artifacts completely neutralizes the historical barrier to entry of elite institutional brand names. First, choose your path. Decide if you are an orchestrator, managing workflows, or a builder, engineering systems. Second, focus. Ensure your educational time yields real-world AI applications. Finally, calculate your true return on investment. Weigh networking needs against the reality of tuition debt. Success in AI requires rigorous, data-driven career choices rather than relying on the prestige of old institutions. Please note that tuition fees, course availability, and institutional rankings are subject to change, and prospective students should verify all details directly with the respective institutions before making financial commitments.